Math 1314, Tyler Junior College, Section 1.7, Linear and Absolute Value Inequalities, Solving Linear Inequalities Part 3. In the previous two videos, we talked about solving linear inequalities and representing their solutions as both number lines and intervals. And in the second video, we, dare I say, discovered or rather reminded ourselves about the rule when you switch the direction of the inequality. Specifically, if you multiply or divide both sides of an inequality by a negative number, then the sign of the inequality reverses. In this video, I'd like to work a few inequalities that are just a little bit more complicated than the ones that we saw before. So honestly, the issue with these problems has nothing to do with the fact that they're inequalities necessarily, and everything to do with the fact that the structure of the inequalities. The techniques that we're going to review in this video can be applied to equations as well as inequalities. So let's start with the first one. Solve x plus 2 over 5 minus x minus 1 over 3 is greater than 2/5. This is the type of problem people tend to leave blank on a test. They shouldn't, because with the right strategy and the right first move, this problem is actually pretty straightforward. So what is our good first move? Well, let me write the original inequality because I want to preserve it before I start doctoring it up. And let's think about the reason that most people would be intimidated by this inequality. I think the answer is obvious. It's got 3 fractions in it. Well, what's better than a problem with 3 fractions? How about a problem with no fractions? If you're ever solving an equation or an inequality and it's loaded with fractions, you can, and some would argue you should, get rid of those fractions as your first move. Okay, but how would we do that? Well, remember that a fraction is just a division problem. So to get rid of a division, we do the opposite, multiplication. So let's multiply both sides of this inequality by a number capable of canceling both a 5 and a 3. I know to cancel a 5, I could use a 5, and to cancel a 3, I could use a 3. But I need a number that is divisible by both 5 and 3. So how about 15? In general, you can always multiply by the product of all the unique denominators. That won't always be the lowest number that works, but it's guaranteed to get the job done. In this case, we have 5 and 3. 5 times 3 is 15. I'm going to multiply both sides of this inequality by 15. Now, before we start reducing fractions, it's worth mentioning that we do have to execute the distributive property on the left side because we have a subtraction between these two terms. So I'm going to go ahead and take the liberty of distributing the 15 to both fractions by simply capturing both fractions in their own sets of parentheses and then putting a 15 in front of the second fraction. Now we can start chipping away at it. In the first fraction, we have a 15 times and a 5 divided by, or rather divided by 5. 15 divided by 5 is 3. So let's bring down that 3 and the parentheses because we still have the x plus 2 inside of it. No more fraction there. Bring down the minus in front of the next parentheses. And on the next fraction, we have 15 divided by 3, that's 5. So we have a 5 left over from reducing, and still inside the parentheses, we have an x minus 1. And then greater than, and on the right side of the inequality, 15 divided by 5 is 3. And instead of bringing down 2 times 3, let's go ahead and multiply 2 times 3, which is 6. In retrospect, maybe I should have done the second problem first, because if you'll notice, the second problem now kind of has the same structure as the first problem. Granted, the second problem has more parentheses, one on the right side of the inequality. But if you can get out a good multiplier and hit both sides of the inequality with it, you should be able to cancel every fraction and then proceed. Speaking of proceeding, I think what happens next would be fairly intuitive. We have terms trapped inside of parentheses and we need to combine them, but we can't until we bust them out. using the distributive property. So if we distribute the 3 across the first parentheses, we will get 3 times x is 3x, that's pretty easy, plus 3 times 2 is 6. And on the second parentheses, we're not distributing a 5, but a negative 5. So negative 5 times x is negative 5x, and negative 5 times negative 1 is positive 5. Always be careful when you're distributing and there's a negative in front, it's easy to lose track of it. And we still have the greater than and the 6. They're just sitting there patiently. Now that we've distributed, we have plenty of like terms we can gather. 3x minus 5x is negative 2x. Plus 6 and plus 5 is plus 11, greater than 6. And now we've got it down to a pretty simple form. We can just finish isolating the remaining x. Subtract 11 from both sides. We get negative 2x is greater than negative 5. And then divide both sides by a negative 2. Warning! We're dividing both sides by a negative. That means that when we bring this up here, we got to flip that sign around. The negative 2's cancel, leaving an x on the left. The sign reverses direction since we were dividing both sides of the inequality by a negative. So instead of saying greater than, it now says less than. And negative 5 divided by negative 2 won't reduce, but the negatives cancel because negative divided by negative is positive, leaving us positive 5/2. So bit by bit, you chip away at the things that are in your way, the obstacles in the way, and at the end there are no more obstacles to overcome. Let's go ahead and write this as a number line and follow it up with an interval. For x is less than 5/2, we just have to locate 5/2 on a number line, and remember, when you're only locating one number on a number line, you can put it wherever you want. Why not the middle? The numbers less than 5/2 would be to the left of it, so we would shade to the left. But at the 5/2, we are not including it in the solution because the inequality is less than, not less than or equal to. So the symbol to write on the 5/2 to indicate that we do not include it is a parentheses opening towards the shaded part. So what's our interval? From left to right, this is shaded in from negative infinity to 5/2 with a comma in between. The 5/2 has a parentheses, is already determined, and infinities always get parentheses. So don't be intimidated by large problems. Identify one obstacle, come up with a plan to overcome that obstacle, and then figure out what the next obstacle is to overcome. And by the way, that's a life problem-solving strategy, not just a math problem-solving strategy. Identify one obstacle at a time, come up with a plan to overcome it, then identify the next obstacle until there are no more obstacles left. This one should go a little more quickly because we've already done all the math over there. Well, excuse me, because we've already done a similar problem over here. I invite you to pause the video and see if you can solve this one before I do. If you didn't pause, you're running out of time, because here we go. First move, I gotta do a lot of distributing. Distribute the 5, distribute the negative 3, distribute the 2. If we distribute the 5 across 2x plus 3, 5 times 2x is 10x, 5 times positive 3 is positive 15. Next, let's distribute the negative 3. Negative 3 times x is negative 3x. Negative 3 times positive 1 is negative 3. We'll combine like terms in a moment. Greater than or equal to. On the right side, distributing the 2. 2 times 2x is 4x. 2 times negative 11 is negative 22. And a plus 9. Remember, distributing frees up like terms from parentheses, so that's often followed by combining like terms. On the left side of the inequality, we have a 10x and a minus 3x, and when you combine those, you get a 7x. But we also have a plus 15 and a minus 3, and when you combine those, you get a plus 12. Greater than or equal to. On the right side, there's only the one x term, 4x, but we have a negative 22 and a positive 9, and we can combine those. That will give negative 13. At this point, we have an obstacle we haven't run into yet in this series of videos. We have in previous series, the variable we're solving for is on both sides of the inequality. Remember, your goal is to get the x by itself, and as long as there are two x's, you can never achieve that goal. So we should fix that right away. We have one of two options. We can subtract 7x from both sides to make it disappear from the left, or subtract 4x from both sides to make it disappear from the right. When you're solving an inequality, I recommend getting rid of the x on the right side and leaving it on the left side. That way, when we get to the end, our answer will start with x. So let's get rid of the 4x by subtracting 4x from both sides, which will give us 3x plus 12 is greater than or equal to negative 13. And now it's a straight shot to the end. Just start isolating the x, subtract 12 from both sides, and we get 3x is greater than or equal to negative 25. Remember, when you combine two negatives, you get a bigger negative. And then divide both sides by 3. Or try to. I say try to because 25 won't divide evenly by 3. And we have negative divided by positive, so the answer stays negative. Negative 25 thirds is what x is greater than or equal to. So what's the number line? Well, I can fit it in this space here. Negative 25 thirds is the only number we're looking for, so let's put it in the middle. But we want to shade greater than or equal to. Greater than is to the right, or equal to means we want to include negative 25 thirds in our solution, which means we need a bracket on the negative 25 thirds opening towards the right. And so our interval from left to right is negative 25 thirds, comma, all the way to infinity. The negative 25 thirds has a bracket. Infinities always get parentheses. So when you see larger problems, don't be intimidated. Identify one obstacle at a time, formulate a plan to overcome the obstacle, reevaluate, and ask yourself, what's the next obstacle?